All right, how's it going? All right, so today we're gonna just be reviewing all the topics that we've gone over. And so today and Monday, we're just gonna do a bunch of review problems. And then on Tuesday, I'll give you a test that you're gonna end up taking at your house. I think what I'm gonna do is, because I don't wanna give you too much time to take your test, because I realize that you could, Google anything you want. I want to give you only an hour to take the test, which means that I'm going to set a time that I'm going to post the test, and then it will only be available for you for an hour, which means you have to get it done and submit it within an hour. Maybe it'll be an hour and a half because you have to upload it and all that stuff. Anyways, so more to come on that on Monday. But let's just go over all the topics that we've talked about. So first, altitude on hypotenuse theorem. You'll end up using this for sure in the test. Basically, it says if you have an altitude on a hypotenuse, so like this line here is a hypotenuse because this big triangle is a right triangle, and across the right triangle is a hypotenuse. And this line here is an altitude because it's perpendicular. So what we have is an altitude, this guy, on a hypotenuse. And so the theorem says that the square of h here, the square of that equals the product x times y. It equals the product of the divisions of the bottom there. Don't get hung up on the letters. These letters might not be in the same spots. What you need to memorize is the positions of the numbers or the letters. So since h is here, anything that's here squared equals anything that's here, this little segment, times anything that's here. Okay? And keep that in mind for all of these. The next thing is that b here, b squared equals y, the side that's adjacent to it, y times c, the total bottom here. And then next, a squared, this guy here, a squared, it equals x, the adjacent side, times c, the bottom, the total. And so these three are very important. The last thing you get is you also get three similar triangles. So this little triangle, that little triangle, and the big triangle, they're all similar. Next, Pythagorean theorem. Most important thing to know is it has to be a right triangle for you to use the Pythagorean theorem. The next thing you need to know is, how do you do the setup? It's important that the hypotenuse, the longest side, regardless of what it's called, it could be called c, it could be a number, regardless of what it's called, it has to go on a side of the equation by itself, c squared, by itself. So anyways, the other two legs, a squared plus b squared equals c squared, and you all know that, but make sure you're setting it up right with the hypotenuse on a side by itself. Next, the distance formula. Given any 2 points, you see these green points here, given any 2 points with their coordinates, call this one x1 and y1, call this x2 and y2, you could find the distance between any 2 points. That's the distance formula. D equals the square root of the difference between the x values, the difference squared, plus the difference between the y values squared. But you take the square root of that, that's the distance formula. Next, we talked about Pythagorean triples. Yeah, so these are the most important ones that I've put down. You got a 3, 4, 5. That one happens all the time. You'll see it often. A 5, 12, 13. These are three sides of a triangle that are definitely correct sizes for a right triangle, meaning they satisfy this equation: a squared plus b squared equals c squared. So you got 3, 4, 5, you got the 5, 12, 13, you got the 7, 24, 25, you got the 8, 15, 17. Now I gave you an example here that is neither of these options because I need you to know that multiples of every one of these Pythagorean triples works as well, meaning multiply every one of these numbers by 2. 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. Well, a 6, 8, 10 is also a Pythagorean triple. This helps you out because what if you come up to a problem and you want to figure out, hey, what's this unknown side? Well, if you see that this is 3 times 2 and this is 4 times 2, this has to be 5 times 2. So you already know this is 10. Anyways, next you got the special right triangles. So if you have a 45, 45, 90, the side across from the 45, the smallest side, call it x. Well, the other side, whatever x equals, this will equal the same thing. And so these are both x. And the side across from the right, the hypotenuse, that's the longest side. It's whatever x is times root 2. Keep in mind, if you're given this side, you're going to have to solve for x. You're going to have to solve for x. If you're given this side here, let's say somebody told you, hey, that side is 5. Well, if you're given this side, you're going to have to solve for x by dividing by this radical. So x really equals 5 over root 2. And you could rationalize that because, you know, you don't want radicals in the denominator. But anyways, watch out for solving for x when they give you this side. And then also you've got the 30, 60, 90. The side across from the 30 is the smallest, and its value is x. Let's call it x. You've got to start somewhere. Well, there's a relationship between all the sides. And so the side across from the 60 will be x root 3. Side across from the 90, 2 times x. Lastly, make sure you know the stuff that we did the other day, yesterday, about regular solids and also, or rectangular solids, excuse me, and also regular square pyramids. Okay. The homework is posted in the link. See ya. Have a good weekend.